So don't worry about recreating it. Just try to, as I go through, try to think about understanding. Okay, so let's go ahead and begin. So what I'm actually doing is walking you through a series of decision criteria. Decision-making criteria. Think about this.
Okay, I found this on the web for some decision criteria.
That is so
Yes,
sweet.
Siri, thank you so much. You don't do what I ask when I want to, and you do what I don't want you to do when I don't want to. Way cool. Okay, so I'm taking you through a series of decision criteria, one of which has to do with net present value. If you said you have a discount rate of X, and you end up with a net present value of 0, what rate of return did you actually get? The discount rate of X, right? Whatever that was. And if X is good enough for you, that helped you decide whether or not that investment was an appropriate investment for you. If you have a discount rate of X, and I'll say in this case it's 10% we've been playing with for the last little while, if you have a discount rate of 10%, and you end up with a positive net present value, then you've met your criteria for a 10% rate and then some, and so it helped you decide that yes, this may well be an investment for you. If you have a negative net present value, which would infer that your discount rate or the internal rate of return you actually received was less than 10%, then that might be a criteria that says don't do this, right? So we're looking at decision criteria, and one of the decision criteria is the rate that you want. One of the decision criteria may simply be time. If you are offered an investment and you believe that it credibly can give you 20%, you believe this, and maybe it's all contractual from the federal government even, or your best friend or whomever you're going to believe, and you have the money to invest in it, but you can't afford to have that money out for 10 or 12 years, then time is your decision criteria. Maybe you need to use that money for a child's college fund in 3 years, or as the down payment on the house, or whatever it happens to be. So time could be a decision criteria. No matter how good it sounds, seems, maybe really is, if you don't have the luxury of being able to invest for that long, time is the criteria. Or, I might come to you, and I offered Chris a Shazam, whiz-bang, no ifs, ands, or buts about it, investment that's going to give us 36%, and it's signed by a credible president of the United States and countersigned by the chairman of the Federal Reserve. Really?
Really?
We know that didn't happen, but if it did. But the entry price, Chris, is $50 million. Are you going to invest?
I mean, it's not credible, but yeah.
Well, apparently you have $50 million to invest, and I'm yet more impressed than I already was. Good for you. Most of us plebeians and mere mortals don't have that kind of money to invest. So the amount of money might be a decision criteria, right? No matter how good or believable it is, if I don't have the scratch to put into it, I can't do it. Now, in this case, if it was only 36%, we might move heaven and earth to try to find the 50 mil, right? I'm not sure if we'd be successful, but we might try, because 36% is not enough. So rate, time, amount may be decision criteria. They're what toggle us yes or no for the investment. But there's some other things. Maybe a profit index is another thing. Maybe a modified internal rate of return is another thing. Maybe a payback period, which connects us to the time we were talking about, is another thing. So we're actually going to look now at each of those and simultaneously look at what I refer to as a multi-columnar valuation structure. There's nothing magical about this structure. In fact, you can do in one cell of the spreadsheet everything that's being done on all of this right now. So why would I go ahead and show the whole thing? Because it lets you see what's going on with greater detail. And it's only to be instructive. When you look at the solution set for project investment selection, you're going to see I use this multi-columnar structure for the solution set. Not simply because I think you should, and not simply because it's necessary, but because I believe it's instructive for you. That's the only reason. And so when I ask you for a multi-columnar, I expect you to give me a multi-columnar. If I don't ask for it, then you don't need to do it. But it might still be helpful, because of the way I lay it out. So let's look at what's going on here. What I've got is I've set this up as a model. And you probably realize that a spreadsheet model has an area that has some work going on where you don't enter in any of the values, but you have previously entered in formulas that now are your model. And it has an area where maybe you do enter some items that then are used down here. Such that, in this case, I'm saying we're looking for a 15% discount rate. We have a cash flow at time 0, so that's the most recent period that we have experienced, this one that is ended. It's $40,000. That's going to inform us of cash flows at time 1 and beyond, okay, in this case. We believe that that cash flow of $40,000 is going to grow at a 13% rate for years 1 through 4. These are just some assumptions we're making. And we believe that after year 4, years 5 plus, that the cash flow will grow at the rate of 5%. So we've created an explicit period, we've kind of synthesized one, and we've created another period for our continuation with a different rate. And in this case, we are supposing that we're going to have to pay $460,000 for this investment. It's going to yield us cash flow starting at 40,000 times 1.13, because the first cash flow is a year after year 0, right? So it expands at the 13%. So I put the 40 here, I put in these variables, and my model goes ahead and begins to populate, and it knows that it puts in here the cash flow of 40,000 times 1.13. And then for the next year, since I said for the first 4 it grows at 13%, it does the same thing, and the same thing, and the same thing. Expands it at 13%, just exactly as we've suggested in our model. So we're synthesizing an explicit period rather than having forecast it by looking at revenues and expenses. We're just trying to simplify this for instructive purposes. Okay? So in this column, I have the calendar oriented years. I start at year 0, which is now, year 1, which is the end of the year in front of us, year 2 is the end of the next year, and so on and so on. I'm only going to have it for 4 years, so I show those for 4 periods. But I show the 5th, and the 5th period takes the cash flow in year 4 and expands it at 5%, just exactly as my inputs would suggest. Okay? So my first column is giving some time elements, and you'll see over here why those become important, other than just to look at them and keep it straight. And here, notice I've started at the last year of my explicit period, I started over at 0. Because that's time 0 is the last year of my explicit period for my continuation term, right? And the next year is year 1 because it's the year after time 0 for continuation. It's the year after the last year of the explicit period. So, in the next column, I simply am going to take the present value of this cash flow, just as it says, the present value of the cash flow. Well, how do I do that? I take the cash flow, and divide it by 1 plus the discount rate to the power of 1. 1 plus r to the t, exactly as you've been shown to do. Looks a little more complex than that, but it's not. So I put that number there. And the next one is the same thing, but it's for the next year's cash flow. So I'm simply, in this second column, I am discounting these cash flows at this rate for this period of time. I'm just putting the number there.
Sorry, what was that again?
So in this second column,
The second column where you
let me say it again for you.
Okay, all right.
In the second column, all I'm doing is calculating this cash flow, whatever's in the first column,
Okay.
by that rate and that period of time. So I'm giving it the present value of that cash flow. $45,200, but we don't get it for a year, and at 15% discount rate, so it's going to be discounted 15% this year. It's only worth $39,304 to me in today's dollars. That's its present value. Does that make sense? We good? Not yet.
Yeah, I've seen it digested.
Okay. In the third column, I have a summation of what's going on in this column. So that's why in the third column, I have the same number here because the 39,304 plus nothing came before. And the next one is, not surprisingly, the 39,304 from the prior year plus 38,620 from this year equals then the 77,925 for that year. So the third column is simply keeping a running total, right? Well, if the present value of the discounted cash flow is the sum of the discounted cash flows for rate and time in the explicit period, then this number here, the 153, 163, should be the present value of those discounted cash flows, right? Because I'm summing these discounted cash flows in a running total. Are we good? Can't tell. Nod, fall asleep, do something. Thank you. Thank you. Okay. So that gives me the first part of my equation, PV of the DCF. Now I want PV of the CV. So I'm going to slide down here a little bit. Where you see I've got the present value of the discounted cash flow, which I've simply repeated that number from up there here so I can see it again. Okay? And now I want to find the continuing value. Well, what is the continuing value? It's going to be the cash flow in time 1 of the continuation, which in this case is 68,479, divided by R minus G. R is 15. G now is 5%, right? That's my long run growth rate. And if you could see, we're highlighting those inputs up there, the R and the G and the cash flow it's coming from. So that number is the 68,000 something divided by 0.15 minus 0.05 or divided by 0.10. And that's the continuing value. But because that continuing value is a value at time 0, it lives here in year 4, doesn't it? It doesn't live in year 1. It doesn't live in year 0. It lives in the 4th year of the explicit period or the last year of the explicit period, which is year 0 of my continuation period. Remember when I said that I thought the most counterintuitive thing we would do is think about this explicit period and its temporal signature? So let me do the timeline over here again real quick to make sure that we're all on the same page with it. And in blue, I've got real time, okay? I'm 0, 1, 2, 3, 4, 5, 6, and so on. Those are actual or incrementing calendar years, okay? If my explicit period is years 1 through 4, then in continuation terms, my time year 5 is continuation year 1, right? Because it's the first one after the end of my explicit period. And if this is year 1, what is this? Year 0. Okay? So when I look here, and I've said that my continuation value, which was value at time 0, equals the cash flow divided by R minus G, this continuing value lives in year 4, doesn't it? It's when it's been calculated as of. So if I want to turn that into a present value, I have to discount it by dividing it by 1.15 to the power of what? 4. Because that's the number of years from now that it lives, and then the amount of time I have to discount it back, which is exactly what I've done. Okay, I'm sorry, that's the continuing, here it is. So I'm dividing it by 1.15, the exponent of 4, and what I'm dividing is the continuing value. Okay? And then my present value is 544,699, which is simply the sum of the present value of the discounted cash flow plus the present value of the continuing value. And that is my present value. That is the value that I would reasonably expect to pay for the asset if it was credibly going to give me those cash flows in the future that I would then own, and if my discount rate is 15%. That's the value. I want to pay less, but that is the value I would be willing to pay if I'm going to hold firm to my decision criteria of 15%. I've simply done it in a multi-columnar form, and the only reason this part down here is way down because I've got my model set up so I could have done many more years of explicit period if I had wanted to.
Can you go back to the cell, the continuation value?
Right there? Okay? So all that is, Ken, is my cash flow at time 1 of the continuation period divided by the discount rate minus the growth rate.
I thought you were talking about time 0, that's all, I just wanted to see.
Okay, so it gives me a value that is as of time 0. So that continuing value is as of time 0, which is why when I discount it in the next cell, I'm taking that value that I calculated, 684,000 plus, and I am discounting it by dividing it by 1.15 to the 4th, because it lives at time 0.
Oh, okay.
So when something lives at a point in the future, and we want to find out its value today, we divide that value by 1 plus the discount rate to the power of however many years out that time is. And our time 0 in this case is 4 years from now. Please.
Right, quick question. So just in layman's terms, the PVCV is basically the present value of the cash flow,
No, it's the present value of the continuing value.
which is only the period that I'm estimating beyond the first 5 years.
It's our terminal value, it's our continuation term, is perpetuity based.
And DCF is for the, okay, so we're splitting the explicit and the continuous, and we're at, okay.
Exactly.
Okay.
So I calculated the present value of the discounted cash flow of the explicit period plus the present value of the continuation value, all back to today. I discounted them to give me a number that lives today. Because we make decisions today, right? Or maybe about things that affect us tomorrow, but we make them today. My expectation is that seeing this for the first time, yeah, you kind of get it, you kind of don't get it, maybe, but I'm trying to give you enough information so when you look at it online, because it's there for you, you can then fairly easily figure it out, instead of just having to look at it from scratch and just play guess what was on my mind. Okay? Which we do sometimes, and it's never my intent, and I apologize. Okay, so they gave me a present value. Well, let's assume for a moment that present value, $544,699, let's assume for a moment that that's what I was asked to pay for it. I want to now think about net present value. Unfortunately, that's not quite as simple as I would like. Hang on, something's happening here that I have to think about for a moment. Oh, it's right here. Good. All right. In Excel, there is a net present value function, and it is equal NPV, parenthesis, and then some stuff. I'm going to show it to you. But we're not going to use it with our original series of cash flows, because that net present value equation does not understand times 0. It is a formulaic issue inside of Excel. I'll give you a link in a little bit here if you want to read the article that talks about it. It took me hours to figure this out when I first encountered it. I found an article that was talking about it and thought, what the heck were these guys thinking? Why didn't they do it right the first time? But the net present value function doesn't understand time 0. It starts at time 1. Okay? So we've got to do a couple of things to be able to fit this neatly into the net present value function. The net present value function wants to know what the series of values are and what the discount rate is and such, right? Which you would expect it to.
Yeah.
But I can't just give it these series of values, not only because it doesn't understand time 0, but because this isn't the entirety of the series of values. This one goes on in perpetuity, and I don't know how to identify a range that is infinite. So I've had to do something else. And in this case, what I've done is I have replicated my cash flows directly from this other side, right? This cash flow here in this cell. Can you all see that? Let me take this up on the screen a little bit. I realize some of you might not be able to see it. I apologize. So this cash flow of 45,200 is simply my cash flow in my first period. Okay? The next one is simply my cash flow in the next period, so on. But this one is different, isn't it? This is not the 68,000 we have over there on the left. But what it is that 65, ooh, hang on a second. Okay, that's all right. It's the 65,214 because that's the cash flow for time 4, plus the continuing value that lives at time 4. Remember, 300 plus 4,414.28, same thing. So that then becomes my cash flow at time 4. I've put in a cash flow at time 0, which is the proposed price of the investment. And in order to calculate it out, in order to calculate it out, I have both ways of calculating. Remember I told you the net present value is the present value minus the investment? Well, if the present value, which we calculated down here at 544,699, if that's our present value, and if we happen to pay 544,699, the present value is virtually 0. In this case, it's 42 cents because I left 42 cents off of that. Okay? It's 42 cents. But the other way to do it is through the function. So my function is, let me move this over a little bit so you can see that whole equation. Net present value is equal to the discount rate, that's the first thing it wants, which I have up in cell E4, 0.15, comma, the string of values starting at year 1 and going as far as I have them, which is year 4, close the parenthesis. So that's going to give me the present value of my stream of benefits plus the present value of my cost. And the reason that that's negative is because I'm adding it here. Okay? And I had to do this kind of in a two-step fashion because Excel doesn't understand time 0. From where they get the will to live, I don't know. Okay? And not surprisingly, it gives us the exact same number as we have here. Now, with this having given us a net present value of virtually 0, when you're talking about $500,000, isn't 42 cents 0? Right? It's a rounding error, right? When we give this to us, what rate of return did we actually get if we bought this investment and it gave us those cash flows discounted for that rate in time? 15%, exactly. Okay. So let's change the scenario a little bit. Let's assume for a moment that I was a good enough negotiator. I only paid $490,000 for this. Would that I could. The net present value from either of the different ways of calculating it is not surprisingly $54,699. If I take the actual present value minus my $490,000, that's what I get. But if I also take and use my function, I get the same number. But now, since this is a positive number, one of the things I know immediately is my actual internal rate of return is greater than my discount rate. And in fact, it's at 18.47% IRR, greater than 15%, because this is greater than 0. Notice that the modified internal rate of return is less, because the modified internal rate of return supposes that the excess cash flows are being reinvested at the discount rate of 15%. I'll show you the function for this in just a second. Super simple. Okay? Let's look at it a little bit more obtusely. Oh, please.
was gonna say, could we see the function for the IRR real quick?
Yes, sorry about
IRR.
that.
IRR.
It's exactly what you would expect it to be. IRR, or equals IRR parenthesis, and just bring up the series. And in this case, ironically, it does understand time zero. I don't get it, but there it is. We're not going to change Microsoft, we're going to live with it. So we figured out how to do it. But it's super simple, right? Okay. Let's assume for a minute, I mean, 18%, that's good, but it's not, wow, Shazam, amazing good, right? Not earth-changing good. So let's assume that I was actually really good at negotiating, and I only paid $100,000 for this. Well, now, I know my net present value is honking, right? My net present value is great, such that I calculated an internal rate of return of 92%. You begin to see the disparity that results by using a flawed valuation estimator. Okay? IRR is flawed, and it is commonly utilized throughout finance. So we're going to use it some. It's a good comparative metric. If you're looking at the IRR of one thing versus the IRR of another thing, it's not wrong to compare them. It's wrong to believe that's what you actually get. Okay? It's not wrong to compare them. These are comparative metrics. They help you make decisions. Okay? And you can see a big difference, 92.5% versus 75.5%, big difference, 17 points plus, right? So let's look at the modified internal rate of return function. A little bit more complex. In fact, let's actually show you the function without it being populated. Equals MIRR, open the parenthesis, and it wants us to give you the values, or the string of values, the finance rate, and then the reinvestment rate. So the way that they've written the function in Excel, you actually can have multiple rates. A discount rate, which is the finance rate, and a different reinvestment rate. Maybe you're looking for a 10% return and you believe you credibly can get it, but if you were getting it, you would be reinvesting your returns in treasury notes at 2.5%. So you could do that. I'm not sure why you would, but you could do that. It gives you the flexibility of giving two rates. So now let's go ahead and look at what I did. Modified internal rate of return. It picks up the string of values, picks up my cost, picks up my benefits, understands time zero, and then in cell E4 is where I have my discount rate of 15%. And I use 15% for both the finance and the reinvestment because that's what I was looking to do. You wouldn't have to, but you'd have to have a reason not to. Okay? So MIRR is pretty straightforward in Excel as well. Any questions about that? Okay, good. I like that. All right, let's talk about payback. Let's talk about profit index. Let's talk about then the case, the project investment selection briefly, and then we'll spend a couple of minutes on sources of ROIC and growth, but only a few. We'll hit them again a couple of times. Okay, it's getting a little bit late for everybody. I know that. It is for me as well. Matthew?
A quick question. So for the MRI equation, so the first one is the finance rate and then the reinvest rate. In a normal world, this would not be the same as a discount
Well,
rate?
they might be. It might be. It's giving you the flexibility of not having them the same. So you're a real estate investor, and you happen to have bought a project cheap, okay? And as a real estate investor, let's say you know you're risking when you invest in real estate. We saw about 10 years ago that real estate's not necessarily a sure bet, right? And so you're willing to put some money out there at risk, maybe expecting a 17 or 18% return because you know there's a little bit of risk to it. But your returns, your excess rents, you want to reinvest those super safe because when you get that money back, you don't ever want to risk that again. You've taken your shot, now you want sure things with your future investments. So you could separate the finance rate, which is the discount rate, and a reinvestment rate, which is what you would think you would be reinvesting those returns at. Or it could be the opposite. You had a treasury bond at 4.5%, and in your mind, as long as you got the money back, you were fine, and you know treasury bond's going to give you your money back, any returns it gives you, you're willing to put those at risk. So your discount rate maybe would be the 4.5%, your finance rate, and your investment rate might be some other aspirational rate. Okay, so you got the flexibility is the point. I've never seen a tool that lets you separate it like that other than Excel. There are some calculators that will work on this. They're far more complex than our HPs, but none of them let you separate the rates. It only uses the discount rate. Okay. Okay, so let's talk about the concept of payback, modified payback, and profit index. Okay. So payback period is not surprisingly exactly what you think it is.
Is modified payback the same as discounted payback?
Yeah, very good. Modified, in fact, did I say modified? I meant discounted payback. Yeah, that's why they're the same to me, because I screwed up the first time and you got it right, which is a pattern we've repeated before, haven't we, my friend? Okay, so in this case, I'm now assessing my payback and discounted payback, and my payback is non-discounted, suggested by the difference in the terms. So I put here, remember I only paid $100,000 for this thing, right? So after the first year, I got cash flows of $45,200. 100,000 minus 45,200 is negative 54,800. It hasn't paid itself back yet. Pure and simple. Next year, I get another $51,076 in cash flow. Subtract that from what I've already got, or add that to what I've already got because it's giving me that. I'm still in the hole a little bit, right? On a non-adjusted, non-present value basis, just a very simple way of looking at it, I still haven't been paid back. However, if I get another $57,715, I now, sometime between the end of year 2 and the end of year 3, I got paid back. So my payback period then would be 3 years. By the end of year 3, I got paid back my original investment. No consideration of return, no consideration of discount rate and time. I just got paid back simply. Which may be good enough for you. You've heard the term, I want to know first I have a return of my money, then I'm concerned about the return on my money. This is a return of my money. Okay? So the discounted payback is exactly what you'd expect it to be. It's going to go ahead and take my original $100,000 that I paid for it and subtract, and that's a negative, and then add to it the present value of my cash flow. So now I am discounting for rate and time. I'm being more realistic about this now. And when I did that, I was in the hole even more because 39,003 is less than 45,002. So I'm in the hole. Doesn't surprise me. I do the same thing the next year. So I will go ahead and add 38,620 to my negative 60,695, and I'm still in the hole, $22,074. And in this case, sometime between the end of year 2 and the end of year 3, as I got this next cash flow of 57,000 discounted because of the time disparity down to 37,949, I break the zero bound, and I'm now in positive territory. And the reason I'm saying sometime between the end of year 2 and the end of year 3 is I've not specified necessarily in just looking at this when the cash flows come. But if you look at my calculations, I'm suggesting the cash flows come at the end of the year. Okay? So by the time I get this cash flow at the end of the year, I'm now made whole. That's the discounted payback. It's only coincidental that in this case they're both 3. Down here, they're both 3. If our discount rates were different, our cash flows are different, they may well be different number of years. Just depends on how it works out. And when you look at my spreadsheet, you'll see how I've laid everything out. This will help you understand before you look at it, just so it makes it a little easier for you to do. So the final item then is profit index. So profit index is a bit of an ethereal decision criteria. But it is a decision criteria that many professional investors, private equity included, use. In fact, you might even think of it as a multiple. I don't want to go too deeply into that, but you might do that. Some of you understand multiples. Okay? So profit index is calculated by taking the net present value, or rather the present value, divided by what it cost us. The present value divided by what it costs. Profit index is equal to the present value of the investment by the present value of the cost of the investment. So essentially what it tells you is what it was worth versus what you paid for it as a ratio. If what it was worth divided by what you paid for it equaled 1, that means it was worth exactly what you paid for it, right? And when I say worth here, I mean it's estimated worth. I'm a firm believer that something is worth exactly what you paid for it, regardless of what you estimated, right? Because you set the market when you paid it. Unless there's some really extenuating circumstances, like you have somebody over a barrel, right? It's just a ratio of its estimated value divided by what you actually paid for. So a profit index of 1 probably meets your decision criteria if your discount rate is an accurate reflection of what you expect. Profit index of greater than 1, cool, right? It had an estimated value far greater than what you actually paid. A profit index of less than 1 would be like having a net present value of less than 0. Means you would be getting a rate of return less than what you expected. So time is a decision criteria. Whether or not you have enough money to make the investment is a decision criteria. The net present value compared to 0 might be because it infers whether or not you're getting the rate you expect to. The internal rate of return or modified internal rate of return might be decision criteria. Profit index is a decision criteria. And with that, you now know every one of the items that you need to think about with respect to practice homework 2, and the problem set. Okay? I would do the problem set, I'd finish the last part of using CAPM and WAC, and then I would do the problem set for project investment selection before tackling the practice homework, before tackling the homework. I'll pass those down, please. So let's briefly walk through this. I think it's going to be pretty self-explanatory to you. I'll give you a moment to read it and clean some of this up. Yeah, we have, okay. And again, you have the Word document online and you have the PDF of the solution online. So in this, I give you 3 different investments to consider. So you're going to have to make a decision amongst these different investment projects. And I ask you to create some values for each one of them. Flip the page and you'll see that my first question is about Don Treader Enterprises, which is the first of these. Provide the firm's calculated valuation, the net present value, IRR, and MIRR. So I want you to replicate using the kind of metrics that I've just shown you. I want you to replicate this multi-columnar valuation structure. And again, remember that one of my Excel templates is titled Decision Criteria, and it's what I was just showing you. So you have the format. Now, I showed you a format and I restrained it to 4 years, but you can modify and manipulate it to 6 years, 7 years, 2 years, 5 years, 29 years. You can do a lot of things if you have any proficiency at Excel. And if you have a difficulty doing that, then I recommend heavily, this is I begged you the last couple of weeks, work in study groups, help each other, ask questions on WhatsApp, and I will answer. And you guys figure out the answers faster than I do usually for you. Okay? So use that. In this first case, we'll just kind of look at Don Treader for a second. Here, Don Treader, Green Energy Company, limited resources, 2 years of financial statement, fine. Firm projects negative cash flows for 3 years of $5 million each. So year 1 is negative $5 million. Year 2 is negative $5 million, right? We don't want this with a, no. And the thing is, Shelby, you're gonna find that this is the investment that I would have selected. You'll see why before we're done. So that's ugly. I mean, negative $5 million a year is just ugly, right? But then, we expect the cash flows to grow at 35% for 5 years, starting at $3.5 million. So in year 3, there's a $3.5 million cash flow, and then for the 5 years after that, that $3.5 million is growing at 35%. That's big. What would cause us to believe that kind of a growth rate of cash flow, especially after 2 years of bloodletting?
Startup.
New technology, right, where they need a lot of debt financing to start up.
Right, so this is not a totally incredible scenario to us, but even then, I can believe maybe, but am I willing to hang my hat on it and invest my millions in it? What might motivate me to do that? Read on.
Backed by a government contract.
Government contract.
Yeah.
Let me breathe it in. Money in the bank, right?
Yeah.
It's the only thing that would get me to believe that, right? Okay. All right.
So the first one is, so negative cash flow for the first 3 years would be.
First 2 years. Oh, 3, excuse me.
Three.
First 3, sorry.
So it would be zero, year 0, year 1, year 2 will be
No.
negative $5 million.
No, so year 0, we don't have a number for yet. Yet. Year 1, negative 5. Year 2, negative 5. Year 3, negative 5. Year 4, 4 or 3.5. Year 5, and for the 5 years extending,
35.
that's 3.5 growing at 35%.
So that's like 4.7, 6 point.
Yeah, whatever that worked out to be.
8.1,
Exactly.
okay.
Exactly, yep. So that's, and so you've got that kind of explicit period, which I believe is going to give you an explicit period of 8 years. The 3 negatives and then 5 beyond. Okay? You've got to project the cash flow for the next year because you need the cash flow at time 1 in the continuation. So whatever you get in terms of the cash flow in year 8, you're then going to grow that at what our long-term growth rate is. Growth projections beyond that period are expected at 8% annually. I'm reading from about the middle of that paragraph. So 8% is my long-term growth rate. So you got the long-term G, you've got your cash flows in the explicit period. What's our discount rate?
30. No.
20.
20%. Where does it say?
Risk-adjusted discount rate at 20%.
Yes. So that means that's what these investors expect. Okay? All right? Now I'll give you a couple of things. Market returns for a firm similarly structured are 9%. You've calculated beta factor for a firm of 1.4%. So you're kind of tempted to try to create a whack, aren't you? It's a red herring. Don't do it.
No
Don't do
whack.
it. It's a trap. Okay? But you're given another piece of information. The firm is seeking funding based on a $25 million valuation. So that $25 million might be your cost if you met the seller's requests. So that's your cost at year 0. Now you can give me a net present value. Now you can give me an internal rate of return. Now you can give me a modified internal rate of return. If you don't have a cost, can you give me an internal rate of return or a modified internal rate of return? If there's no cost at time 0.
No,
Why not? I agree. Why can't you?
because then you don't have anything to base how much you are making back on the investment that you.
Yeah, there's no,
initially
you haven't invested anything to get a return on. So there must be a cost and investment to give me an IRR and MIR. And you can do profit index, you can do payback period, you can just sing yourself to sleep. Okay? The next 2 projects are different in name and detail, but not different in structure. Although I don't think I give you, well, I guess I do give you some red herring information in those as well. Okay? So I asked you to do Dawn Treader Enterprises. I want the exact same thing with You Can't Get Enough. And I want the exact same thing with By the Way Enterprises, BTW. 3 different kinds of companies. And then I asked you in number 4 to give me something a little bit different. You'll understand it. Simple. In number 5, I say, notice the problematic relationship that happens in By the Way that you'll understand when you get there. It's got a really nasty detail to it that you'll figure out easily. I think. And then number 6, I say, okay, now all of this done, what would you invest in? And how would you structure it? And if you look at the solution set, you'll see what I would invest in and how I would structure it. I would not invest in, by the way, Enterprising. It is a female fashion boutique selling used clothing that has a great track record of profits in their brick and mortar stores. It has some real interesting possibility on online, and I would not invest in it. Why?
Brick and mortar's going on.
Well, maybe, but I think brick and mortar isn't dead, but it certainly doesn't have the preeminence it did, right?
They come and
Do
go
you
so
remember?
easy.
Pardon me?
They come and go so easy.
Well, that might be true as well, but that's not even why. Remember one of the first nights one of you asked me a question, I said, I never invest in things I don't understand? Do I look like I understand ladies' fashion? Let's be honest with you. Don't smirk at me. Okay, let me self-deprecate without you adding to it, okay?
But your wife will help you.
Yeah, that's what she'll do. You'll all have an opportunity to meet my wife at some point. At the end of the year, I do a barbecue at my house, and I invite anybody that was either seniors or in the master's classes. I talk to my house for a barbecue. And at the end of the year means in the spring. Okay? And so you'll meet my wife. My sweet wife is Attila the quilter. Okay? And yes, she does understand fashion. She knows how to spend money on clothes. That's what she does. Okay? So, by the way, Enterprise, I'm not there. The next one, or the second one rather, is a company by the name of, what was it? You Can't Get Enough. Which, when you read through this, you'll get it. Can't Get Enough is a barbecue place. It's a franchise play. The fastest way I know to lose money, I don't ever believe the estimates. The fastest way I know to lose money is to invest in food service, restaurants. The second fastest way I know to lose money is to invest in franchises. This is strike 1 and 2 all rolled into one. So I don't love them, but you guys might be all over it. You have invested in food service, right? Yeah, you might love it. I won't. You're great at it. Cool. You don't have to invest in something you don't like. You may just not pass your smell test. Remember, it's your money.
But should it be just based on the numbers? Why don't, I mean, these kind of
Because
decisions
it's
are-
not. Yeah, in a perfect, I'm totally rational world, never influenced by my whims, sure, Madison. But I happen to stand here as a biologic entity with preferences and tastes and discriminations, right? I don't invest in food service. I don't invest in companies I don't understand, period. Now that might limit me, but in this huge universe of investments we have available to us, I'm not all that limited. Yeah.
And it really makes sense, at least the first portion of it, where if you don't understand the industry, it makes sense to stay away from it. Because I mean, there's a lot of industries or companies that seem to be profitable, like in oil and stuff like that, but you don't know how politics play. You don't know if this country does this, how is that going to affect the market. So, just like you say, if you don't know how like every single part as it moves affects that company, it's just best to steer clear from it.
Exactly. By the way, Warren Buffett doesn't invest in companies he doesn't understand. I took my rule from him. The first time I heard it, I kid you not, I said, thank God. Because I knew that I didn't like to do that, I didn't want to do it, and now I had somebody very credible echoing the same thing. I felt as though I could safely do that. Okay? When you're making private equity investment or venture capital investment, you're not investing just your money. You're going to help make decisions, right? And if you don't understand the company, how can you help make decisions? Okay? I've just introduced 2 more decision criteria to you, didn't I? One was, and these will both fall under the settings of your own personal rules. For mine, decision criteria is I don't invest in what I don't understand, and 2, I don't invest in food. Okay? Those are 2 decision criteria of mine. They're discretionary, they're subjective. They certainly may not be yours. Having your own decision criteria is absolutely necessary, or you'll be buffeted by the winds of change and loss. And that's not fun. Fair enough? Okay, it's after 9 o'clock. We're going to push off sources of ROIC and growth again. We'll get to it, I promise. It's not trivial, but it doesn't have to hit a sequence for some of the mechanical work we do. And with that, we're clear. Come get your, using Cap Edmund Wack, Shelby was kind enough to note who has given them to me. I'm going to keep the math of value creation so I can deal with those, and I will see you guys next week. Hazel, would you please turn off the recording?